metal and alloy, but not high temperature. Okay, so yellow is plastic and resin and polymer, and triangle green is ceramic and hard metal. Why? Because hard metal is very difficult to melt, so we need to use chemical reducing back and grinding, so different. So this is so many ways. So this first one is machine way. Machine way, I think everything is machining. Yeah, use physical force to broken materials. The powder, the shape is not circle. It's a very strange, many kind shape. It's a very the geometry is not a regulation. Okay, so this one is big and rough. Okay, so we can use cutting machine. Okay, so the particle size is very big. Maybe it's bigger than 100 micron. So we cannot easily use this one in normal process. The second is we call this one is milling. Milling is we use a milling ball. Use for example, we want to get the tungsten carbide. Tungsten carbide, we call this one is a WC. Not the toilet. It's a tungsten carbide. W and the C. Okay, this one is very hot. So we use the tungsten carbide ball. Big, small, many together, then milling. We call this one is ball milling. So every students will meet the ball milling machine. You will do the ball milling. Why? Because you need to modify the powder surface condition, the powder size. So the milling is a very popular way for powder size. Okay. So this powder size depends on the milling time. Okay. So many kind of materials can do this one. Okay. Then number 3 is automation. Automation is melting. Melting the materials like the soup. We call steel soup. We call stainless soup. Okay. Then to spring. You just do you have use spring water for your flower for your plant? Okay. The pressure and the liquid will be through the pressure and the atomization. Okay, and make small particles. Okay, so this one is popular in MIM, popular in metal AM, but the PM is don't use this one because this one particle size is very small. This particle size is also smaller than 70 micron, less than 50, maybe less than 60. So it's very small. Okay, but we use this one normally. Okay, and this one is multi-spray welding. Okay, this one is material is melting, but not use high pressure spray. Just boil down. Okay, and this one is we use the spring disc. The spring disc is cold. Spin, very high speed spin, then melting the melt go into the disc, and this one will spray outside, and the size is big, and the shape is flat, it's not a ball. Okay, so this one is we call this one is melting spray regulation. So this one is big, this one is small, and this one is electrical deposition. This one, like copper, we will use this one. This one, like copper and like the cobalt, use this way. Okay. Then this one is reducing weight, that's no weight. Reducing weight, or we call this one Carbonium method. Carbonium method. This one is reducing chemical and reducing control the pressure, different pressure. The powder will become from the solution, then become a solid powder. Okay. So this one is more fun. So in MIA and the AA, we use this 2 ways. microscopy. This lens is 5 micron. This is 1 micron. So we can check every powder is very small and like a ball. Why? Because this one is in the tower, we make the general solution inside. So like in hair, grow. Okay, so the CIP powder, carbonyl iron powder, like the hair forming process. Okay, it's inside, go out, here. So you will make it like one layer, 2 layer. In Asian people, Asian students never to play the snow. Do you play snow? No, no. If you go to Japan, go to America, you can play the snow. So we just watch the cartoon, the snowball. Okay, one layer, and one layer. We just package it, then cover this one. Okay, you can catch this like a tree. Okay, one layer. This powder will become big. Okay, but the size is 1 micron, so we can get a very fine powder. We call this one carbonyl iron method. This way is called carbonyl iron. Carbonyl iron can do a lot of kind of material. First one is iron. First two is second is nickel, nickel, N-I-C-K-E-L, nickel, nickel. The others we can do the chromium, good. So it's just a few powders can do by carbonyl process. This one we call carbonyl process. Okay. So carbonyl iron. Nickel. And maybe cobalt, maybe chrome also can do. Okay. So this one is a reducing way. Okay, this is iron and 5CO together, and 200C and 200 bar, it will become the gas. Then, like this one, we go to the other chamber, we just up the temperature to 300 degrees C. But the pressure will be lower, then this powder will be outside. And this one can be recycled. But this powder shape is like a ball. Okay, so we call this process as carbonyl process. Okay. This second picture is we call augmentation. Augmentation process is easier to understand. It's melting the powder like the soup, and everything is inside. Okay. Then go this one going to a tank and spraying. Okay. So sometimes we make some coverings for bucket without any oxidation. But normally stainless, we don't need this cover because stainless don't afraid oxidation. So just can in the air, no problem. And pour into this nozzle in here and spray. Okay. So sometimes we use the gas. Sometimes if the gas use the gas is more slow, low pressure, so the powder will become like a ball, very good. But speed is not good. Why? Because every minute is just about 10 gram, 15 gram. So we exchange the cooling gas. Maybe we here, we enter the high pressure water. So use the high pressure. So use the high pressure water. The cooling rate will be high, and because the pressure higher, the particle size should be small. And another circle, just like the potato, but we can get more powder quickly. So we call it unit gas and water unit spray. Okay, so this one is a normal. Okay. So we just get the 3 kind of powder. Okay. This one we call this one is a gas atomization. So you need this one. Every piece like a gold, but expensive, and its quantity is small for production. Okay. The means this one is expensive. This one is water atomization. Okay. This one is more quick. The problem is many powder will stick together because speed too high, and the size and the shape is not good. So we just use this way and this way combined together. We call this one we say it's gas water atomization with annealing. So sometimes we will use we call this one unit atomization. Okay. So you just watch this powder like a potato, not really like a ball, but this one is more cheaper than this one, and it's a geometry better than this one. So this one is good for MIM process, but not good for metal AM. If we use metal AM, because you need a spread powder very flat, you need to use circle powder. So these are 2 measures. But MIM process, if this one smaller than 30 micron, we all can use. But this one just more cheap. And in mainland China, now this one is a very cheapest and a very big quantity. And the second is this one. Yeah, because this one good price. Okay, so everybody do this one or do this one and make it very here. Okay. And this one now recently is just for PM. But the particle size should be big. Why? Because the speed is very high. So we just use this one is changed to 100 micron. Then we can get it. So this one easy for PM. This one is for MIM. This one is for metal. Okay. So we just separate 3 processes. Okay. The PM is 17 to 150 microns. So the size is different. So just remember this one. And this is B. So you need this size. But if you just say, I just do it by metal AM, the cost, he will sell you a really good price. But you just say, okay, I want to make this your big powder to do this one more cheaper. Okay, so remember. Okay, then the material limitation is we just not recommend the 9 metals. Okay, so very interesting. Last week I just said 3x. Number 3 is very important. Okay. Aluminum, magnesium is too dangerous. Can do, but just please take care, please, because this one is high additive materials. Heat maybe will burn, maybe will explode. So when powder size is small, you just to take care. Okay, even you meet some in American has how many 谷仓怎么讲 storage 米的谷仓，稻米谷仓。美国没有这种稻米，我还是玉米charcoal的 storage。Yeah. When you storage the charcoal, okay, the small particle, when he flash, okay, in the air, in the space makes a small piece powder inside. If somebody take a cigarette, it will burn out. It will explode. So every powder is dangerous when the size is small, so should be taken. In China, many times for 3D printer for this one. Aluminum and 10% magnesium and silicon, these are materials. And during SLN use 15 to 55 micron powder. Okay. When they do the selected laser melting, okay, when they do the job, it's nothing. But the operator forget about this one is line making. So he want to this is not smoothing. After 10 minutes or 2 minutes, he find the field without change. My God, during the process, he want to change the field. Normally the field cannot change because this one is aluminum. He forget about it because the last time is do the stainless. So this time he just made this material, just thinking about the same. So during the process, the temperature is higher. He just opened the field and put out. So the aluminum powder, fine aluminum powder in the field, then explode. Okay, so the two operators line up. Then this burning, then everybody is very hurt to move the machine to outside. Then use the water pour the machine. So the second explode again. Why? Because aluminum material or into the water will get the hydrogen. So explode again. So please, you shouldn't be understand which kind of powder. If it's powder, you just use one kind of materials to make this one is for safe. Don't use the water. Use the other or bubble or use the salt to reducing temperature. It's much better. Okay, so 盐吧，这个叫盐吧。So please, everybody in here, if your research topic is about the powder, please understand your powder spec. Okay, everything is physical. Physical is means particle dimension, and understand your equipment. Have any safety equipment or something, or something rule, just asking your senior classmate. It's very important. Okay. So for 3D process, PM, we call PM is glazing and molding. Okay, so most of PM parts is 2D dimension. Okay, just remember. You last time you not come here the video. Okay. Okay. For you, show the video. this one is PM, pressure, press, 这个压，然后整起。Okay, this is parts. This is powder.
Each of the ingredients that will comprise the desired part are mixed in proper proportion into a uniform
Messy.
With pre-alloy powder, the proper proportion of ingredients is already present in each particle. In either case, additives such as binders and lubricants are usually added. The powder is then
It's about 3 years ago. 2 years ago. Now it's automatic.
densifying it into a compact of the desired part.
Parts so
At this point,
Press.
the part or compact is in a green state, where the
How's that?
powder particles are just lightly joined together. In this state, the parts have a so-called green strength, which is usually only sufficient for handling purposes.
okay. Green part without sintering, so it's very green. So we go to the center.
During sintering, parts are heated at a temperature.
Okay, the powder will cut, will closely and naked. Because this one is naked. And the shrinkage, so it's more hole.
Increasing strength.
So because this one is center.
Density is
After sintering, the parts will be
although
strong.
porosity is
Okay, this guy can feel it.
achievable for certain parts.
That's a big
The
particle.
performance of structural parts increases directly with increasing density. The common methods of consolidating and shaping metal powder
Okay, this is the injection molding.
include mechanical pressing, injection molding, and isostatic pressing.
So there are 3.
Most parts are made by mechanical pressing and sintering. Parts are usually small to moderate in size and can be simple or complex in shape. They can be very thin or thick and can also have 1 or more levels, shallow or deep holes, and various other details. Parts produced by mechanical pressing can be net or near net in shape and have very close tolerances. Part production rates are high, from several hundred to thousands of parts per hour. In mechanical pressing, the powder is
Okay,
always
we just watch the after pressing. The parts should look like the solid. So the strength is no good. It shouldn't be sintered.
pressures of 10 to 60 tons per square inch are created by the
But in PM process, the material go, green part go to the center. The shrinkage rate is small, very small. Maybe not shrinking, just only the same size. So this is PM, different MI.
formation of holes parallel to the direction of pressing. If the part being made is thin and uniform in height, the powder can be pressed from one side by the upper punch.
It's input the powder, into the cavity, and remove powder, placing,
The part is then
injection.
injected by a wiping action of the powder feed chute,
This is
which
PM.
also wipes
So we need to use the
into the dye.
raw powder, not the
Injection
fine
of the
powder.
press can
The
also
powder
be
size should be
used
17 to 150.
The density of pressed powder tends to decrease along part height as the distance between the compacting punch and die increases. To produce more uniform density, thin parts are compacted
Okay,
by
the shock,
sections of
the Japanese shock, just more
After
complex.
pressing, parts are
This one
transferred
put
to the
here
sintering furnace.
for sintering.
Sintering furnaces include preheat, high heat sintering, and cool down zones, each having a controlled atmosphere.
3 centuries.
Depending on the base metal of the part, the
Preheating is remove the lubricant and the wax from powder
composed mainly of hydrogen, nitrogen, and carbon monoxide,
and use the hydrogen
which is
or
composed of
nitrogen gas.
nitrogen mainly, dissociated ammonia, which is hydrogen and nitrogen, or entirely hydrogen, vacuum, or inert gas.
Talking about the sintering furnace,
Proper sintering, the heating rate, maximum sintering temperature, time at the sintering temperature, cooling rate, and furnace atmosphere must be closely controlled. Powder metallurgy is a metalworking technology used primarily for producing parts from metal powder.
in this class, the team call this one is powder metallurgy principle.
Parts can be produced in net or near net shape, and to control porosity or nearly full density.
So the PM is very cheaper, is a very high speed, better than the casting. Yeah, because casting is very dirty. This one is more convenient. This is very optimization.
Mechanical methods include milling in
Mechanical way.
rod, wall,
Understand that's
grinding,
the
or nutrition mills. Metal powder used for parts production can be a combination of various.
Okay, so here about
powder.
here
The
about
powder is
20
then
kilo
consolidated in dies or molds.
material. Here the material is using copy. And everybody use the energy USB to copy from the okay.
The common methods of consolidation are mechanical.
You also can find this one in YouTube. You just write down the keywords automatically. Okay. And the principle. It will
The
jump up.
powder is automatically gravity fed into the die and press and consolidated.
Okay, this is for PM. MI just like this one, we just again. It's just a mixing powder in a mixing machine. Then mixing powder binder together, then mix pelletization, the particles, big ground, and go into the machine. This is a deep packer. This is a barrel and a spool, and injection the materials into the mold, into the cavity. Okay. This is a mold. Mold is a molding many cavities, and then this is green part. And green part, this means metal and binder mixing together. Then we just remove. Before sintering, we should be remove the binder. We call this one as debinding. And this way is a solvent debinding. Now we use it's a canceling debinding. It's different. It's a chemical way. This is a physical way. Okay, the waste and the polymer will go outside and leave the metal powder. Okay, this is baking. Then let the green part go back to its original shape. Okay, just baking and remove some binders. Okay, and become brown. So we can brown part. Then we use the brown part. Then go into the sintering furnace. This one is batch type furnace. Use the vacuum and the high temperature. Then the powder will close and close more, and the sintering together become a solid materials. For this one is a silver part. So we can make these parts, many parts, metal, not casting, just for sintering. So we can use the injection mold, like the plastic injection molding way, then get the metal part, like the plastic process. Okay. And now we're just looking at the metal area. This time, 2 days ago, I go to Japan to watch the CNC machining company. Okay, they use this one 3D printing, then CNC together. Okay, the first is powder or the wire, then the laser melting and staking again. So the staking. Okay, then after 3D printing, we got the parts is roughly, material is safe. This is a safe material. Then we change the size to get the other geometry requirement. For example, this way we got this one is flange. This flange this way. So different rotation way, different support. We got the different side features. And we just exchange them. Exchange, use the CNC machining tools and the rolling mini machine. Okay. So the dimension is very closely your requirements. Okay. So this one is a compilation process. Okay, we just take care. Every 3D printer without some defect. Then switch it again. Make this one. The net piping is higher and change its size. Oh. Okay, then continue again. Okay, this machine is DNG from Germany. Okay, make a different way and different features. So this is a special 3D printing, not the powder bed fusion, just only the laser printing. For this one is NJT material jetting. Okay, with CNC. Okay, so this one is 3D printing. And so the powder is more should be bigger. And like this one is. Bigger models. This one we call is SLM, selective laser melting. This means powder is being melted, not keeping the solid. So this one is not a powder method, just a melting process. We just consider this one as welding, like a powder welding. Not assembly. Okay, draw down. It's a draw down. This is a high power laser. Okay. Okay, this is a side view. Power up. Then rolling powder. And go back. Okay. This is before falling. Okay. Then settling. This one is melting. So this one is rolling. Again. Another small 400 watt. And the finish with even powder. This powder is not automatic, it should be by hands. Every 3D printer is it is powder bag. Just rise up and clean the powder. Then we find that you pass. Okay? So here. This here. Okay. Tell me what's this? What's this? Support. Yeah. AV process. Even FIM, even PM, even AM. If this one is suspension, you need support because you are in the earth, you will drop out. So let's move into let's move in the move. Yeah. So if this one, so many support. So this support design is very important. But most of people think about is not needed. In the other side, the other science, they never know the powder metallurgy. They never know the thermal science. Okay, this one not only for support. The other side is for thermal translation. Yeah, because this process very high temperature. Whereas your temperature go up, the powder bed cannot go up because powder without sintering, so the thermal barrier, many thermal barrier. So after this one consolidate like a metal, really metal, the thermal can move from this way, go back, go out. So very important. One is for thermal, one is for thermal issues. We should be separate the thermal. So this is two different concepts that we have to build in your mind. Okay, so any process of powder metal forming should be support, should be considered the thermal translation rate. Okay. Hello, Dennis. Dennis is my classmate. 30 years ago, my classmate. Yeah, 40 years ago. Yeah, 40 years ago. 1975. 85. 83 to 84. Very long time ago. 我的五专同学。And he is very professional for airplane physics. He has a license. This guy is very interesting guy. Okay, so we just watching every 3D printing parts should be good support for keeping its geometry and let the thermal separate translation. Very important. Don't forget about it. Okay, and you just thinking about why. Don't know why. Just only one layer cannot make it more layer because of the thermal. If thermal higher and steady, the materials will be deformation. So in the SLM, in the powder metal fusion, just only one layer. Okay. And it should be removed. This one is EDM wire cutting. WEDM wire electrical cutting. This is so now you know the injection molding PM. So now you know different powder size. Yeah, process make decision by different powder size. Very important. So now this class is just learn PM first, then is MI, and metal AM. Maybe you can require James come in and talking about one time is for service for you. Okay. Then we can understand which one is needed to understand more powder technology. This is MIM is high power science requirements. Okay. Okay. Then the tech density. Tech density means the powder tech density should be higher. So in PM cannot be high because if the powder density too high, it's another ED flow. Because PM, just watching the PM, just is field drawdown. So the particle size cannot small and the density cannot high. Yeah, because you want to like a flow. So you need a big size powder and the bone meter very like a bone. So this related to roundness, just 0.4 is enough. Okay, but the MI should be higher and the NA should be higher and higher. This means if 1, this number is 1, is a circle. 4. Okay, so this is a verb. And MAN need this powder. Why? Because we can either do moving and splitting as a unit. This MIN, this are maybe not good. It's only baking. It shouldn't be a little baking. And metal PM is either more baking, so we don't need this one. It's expensive. Then just choose the small powder, big powder and different shape. Okay? Okay. The hardness requirement is material hardness. So the PM cannot make hardness high metal. If we need, we should add a binder, more binder inside. So the binder is very difficult to remove. So PM just like use without binder, but we just use the soap powder. But hard metal is high hardness. How to do? We just coating a layer of binder in outside. Then we just placing is a binder and the binder, just a conjunction together. Then powder will bring together. Then to center. So it's different. Then this one is without. We just can use hard soap. Okay. And this one is without because this one is melting. We use the binder. Then the surface condition is roughness available is okay. This one is light rough hardness. And this one is smoothing stereo free powder. It means small powder. Actually cannot too much. Just only one powder on the small side. For example. Some kind of powder like this one. This small powder outside. Okay, this one is not good. We need this one. Okay, because the small size powder is not good for process. Okay. So we just seeing how to check. This means we just see and display powder. Okay, 2.1 is geometry. 2.2 is measurement weight. Okay. So here, this is we use science perspective to simulation of the shape. So this one is equal is 1. You can understand. Okay, everywhere is very easy to calculations. And the others is different. We just use computer science to make the simulation approach like real parts. Okay, so this one is not the only way. This one is somebody say, okay, I can use this one. But in the nature, in the industry, we cannot get this one. Do you believe in the nature, the powder will like this one? Do you believe? You think it impossible, but sometimes it's possible. Yeah. For example, if you search constant powder shape, you just think, wow, my God, like this one. Some kind of powder is geometry will change, like this one. Some kind of crystal, some kind of animal, it will naturally become this size, become this shape. Do you watch it? Constant color. Very similar. Okay? But anyway, we needed to count how many pieces in your in 1 gram, how many pieces we use. But this is uncountable, but we just can analysis by what? by some way. So many people, many science to do many things. Okay. So this one is before we just never use the computer. We just use a picture comparison. Use a microscope. Okay. So it's a difficult job, and you spend a long time. When you study in NTUST, you just spend about 2 years to come before. Yeah, so your progressive is very slow. But now it's use computer. You just don't worry about. I just talking about before we use this one, okay? And this one is angular way, okay? Just comparison, but not very detailed, not very advantage. So now we change. So here is your research. When you research, you will many expression will for something property. For example, this one dimension. Okay, this is easy. Everybody can use some scale, something to make this one. This is a pressure and weight, and the pressure also. We have scale, easy to understand. And this density is combined together, okay? So we use level and easy to check the density and the specification value. And the particle size, we need to use the measure. Also, it's a size measure, analysis, microscopy and image analysis, okay? Screen or something. So this kind with more real discussion. And thermal and temperature, okay, we have a thermal scale, we have a time scale, okay, it's easy. And this microstructural check, okay, we use microscopy, okay, this one is during the school, you should be understand where is your OL and the SEM, and the FE, SEM, and the TM. In our school, we have. But in powder science, we need analysis or everything, the SEM. If we use some organic, some polymer inside, maybe we will use the field SEM. 这个有兴趣，对，长方纤维系统。Okay, then if you have to know the element of composition and the space. You should know the weight percent, mole percent, atomic percent, something. You either use the ICP, index, EPMA, and NCOS is the element. Nitrogen, carbon, carbide, oxide, and sulfur. We need analysis. So sometimes we have added with hydrogen. We need analysis. Or the other is SRT and EPSD. This one is electrical backscatter defibrillation in the SEM. We can do it together. And also we just check the mechanical properties, including hardness, strength, torque, pressure, and shock. Okay. So even the thermal shock, we need to understand thermometers. Okay. Then the other is appearance. This one is more difficult. Yeah, because appearance defines depend on many. So this one in future we go to the industry. Everybody call me the limitation samples. We need the limitation samples. Give me the limitation samples. Upper limitation, down limitation. We just use the comparison way. Now it's you use computer, it's very easy. Okay. So last week, just remember, I showed you the video. Again, just check the video. Okay. Loading, and expression by picture. Clean and expansion and arrangement together. Okay, this is your cell phone, iPhone. Take a picture in the 30 seconds and check every detail. So nobody on factory. Okay, nobody on factory. So because this one is very high. Okay, new technology. Okay. So everybody have to know, not really nobody in factory. Most of people is going to in the bank, under the plane in the bank. Everybody very busy and too many people to do many things together, integrating in the machine. Then the machine, the speed, efficiency is high. Okay? Before, without laser technology, we just use the manual inspection. Okay? People is very smart. We just thinking about use the mesh and the mesh. The problem is when the particle size is small and small, it's not easy to do. Why? Because you know this one mesh, every mesh with a wire. The wire, when you the particle size is small, the wire should be small and small. Then the strength is no good. If the powder too small, the mesh maybe will broken. The particle size cannot make it very well. So this way, just only can approach about this one is a mesh is 800, no, not really. Just only 400 is a maximum. Yeah. Okay, this is easy remember is micro and the mesh exchange use 50,000. Okay, use 50,000 you can do this one exchange very quickly. Okay, so use the mesh, then mesh. Problem is this one is cannot miss production. When the small size powder. What means is mean powder cannot use this one. It's no good. No efficient. So we will know this one switch, but we will use automatic machine. Why? We can use this one. Because this one is a gas flow gasification. Okay. This one is the means we just blow a very strongest flow, gas flow, for example. Air gas or nitrogen gas or argon gas. Okay, some kind of powder cannot touch the air because of the outside. It will explode. So we use the nitrogen, use the argon to blow. Then the powder, because the small powder, very important is its size is smaller. Because very small, so easy to blow. So the side, the blow is very more quickly. The powder small size is more longer, so it's easy to separate. Okay, so this one is just talk about how to separate the 500 and close mouth. Okay, we just use this way, or this way, or this way, or this way, or this way. Okay, depending on our pressure, depending on chamber design. Okay, then we can get the fine powder and close powder with efficiency. That's very important. So like an airplane, okay, the jet plane is more good, speed more higher. Yeah. Okay, so this one is Then, how to measurement? Now we use laser particle size analysis. We just use laser wave. This means this is a laser. Then we just suspend the powder in the liquid, in the fluid. Okay. Then we just capture the signals from the deck. Then we can know what kind of powder, how many pieces. Very easy. When you sample, you can capture about 1 gram, how many pieces inside. Okay, this one. So we have also can check this one particle size. Also is understand the distribution. Then we also can understand the geometry shape. Then we also can do both sides closing. It's both or not. Then we just can surface area calculations. So this one is very quickly during the one cycle, about 3 minutes, we can calculation everything. Then this study here, and make the drawing. Then you can understand where is the D50, where is D10, where is D90. Okay. Then here has more information inside. Okay, very important is D50 is average particle size. Okay, it just is a coverage, not like only one, just a coverage. Mean about this sample. When we sample this one powder is D50 is 2.29. Okay, normally it's very fine, but we should be checking the D90. Why? Because when the powder just a little, very small size is big. But when we process, we just take care of the D19 because the porosity may be from here. Sometimes you will make some problem with the porosity because if you have a big particle size, your porosity will like this one. So I have get many reports with James. We make some measurement and we find it's true. So we just take care of everything. So in here we have D0 to D1 to D100. This is 100%. We have this. We just list a little. Normally we have like this one. Okay, this one. There's more. Okay, this is D1 to D100 separate the micros. Okay, we just checking about how many big size. So the powder is start from here. So it's this one is D1 here, then to here is D100. So we just check this in the middle. So this is 100%. Okay. So this one in college, maybe college to 50 is we call D50. Okay. Then you just check. Most of people talking about big size is smaller. We just find the problem is over this one is the D90. Everybody just say, oh, the D90 is not so big. But they forget about from D90 to 99. This voltage is over 8.7%. Okay, and this one is so big. here, this acres is about 1.71 voltage. So after sintering and polish, they just different about 1% porosity in the mirror line, in the mirror side. So you cannot make a solution. So I find this one and to make the mesh and color. We just make a mesh here. Then we just if this powder going to process, this one go outside. So it's successful. Okay. So very important. Should be understand the size of the powder. Okay. So in here is this is 3D printing. Okay. 3D printing every layer is 50 micron, and your particle size should be smaller than the 50 micron. Am I right? Yeah. If the particle size is too big, even this one will be melting. But maybe it will leave there. When next process, it will go outside. This particle without melting, it will go out. Because during the rolling, it will bring up. This will become hot. So should be understand. You design the coating layer just like you make the cold spray. When you cold spray in your layer, how many layers you want to do, and the layer thickness, and the particle size, biggest and the biggest and the smallest. You need to make a drawing comparison. Then to understand how many, how the layer stated, how much pressure, how much layer they coated, and again, layer 1, layer 2, layer 3, and what kind of different file. Maybe it's depending on particle size. Okay, understand? Oh. So the before, this one is another by digital lines, but now it's digital, so easier. You don't need to use this one. We just use line comparison. Okay, this one we can understand. So this one is really old. This one is not good. Maybe MRI is either. Okay, this is simulation by 2D. We can use simulation by 3D. Okay, this one is different. So any powder like this one, sure. Many powder like this one. You need to modify. It will change to like this one or something. So this is very interesting. In powder area, it's very interesting. So in the future, if you graduate from NT University, should be about this one. And co-helper for me. I'm your biggest supporter. No problem. Okay. Okay. Then after you watch the SDA, okay, this is 18 nickel 300. This is a special tooling steel for AM SDA. Okay, you just watch it and say, oh, this one very beautiful. Am I right? Every particle like a ball. Yeah, like a ball. But sometimes you have a connection together. Normally it's like this one. So not everything is ideal. We should be understanding. And this one is a ESD analysis 3168 microscopy. It just can watch the Austin line face. So you need to research what kind methodology face analysis, what kind of way to understand this one. Okay. This conclusion here. There is no correct answer. The plastic and truth only. So do everything by yourself. If Dr. Q says something, you need to prove by yourself. It's very important. Okay? So this session is talking about power science. Just basically, you don't worry. This one is very simple, but you need to thinking about This range, how many pieces you cannot uncountable, but you can know the range distribution. Then use the distribution, the range, and thinking about what kind is good for your process. Okay, you use the AM, use the PM, use the MIM, you use the powder coating or something. You're just thinking about the particle size. Okay, don't use the big powder with a small size powder. It's difficult. You need to do something to bind them together. You need something to separate. You need to modify by more mini, by something. Okay, so we have so many ways. So if I'm not here, the James, okay, James also is a student of the team. And he is a senior classmate of my team. Earlier going to the university, but go to the industry. And just only like you. This year I asked him graduation from here. It's very important. Okay, so this one is in your idea. Please keep it in your mind. This is a very famous sentence from Dr. Kim. Yeah, okay. It's very important. Okay, then we have to do smart job. What is smart job? Seeing, meaning, analysis, research, and so on. So we call it SMART. Okay, this is SMART job. In here, you stay here. This is TUST. Okay, every students like you. If we want to good result in the future, get more money, the same. Okay. Okay, then this is one small session. For OSF, okay. We're just talking about mathematical simultaneity. Okay, I just write down this magazine, not a paper. Magazine in PIM International. Everybody can check this one. Okay, but very interesting is only this one. These equations, okay? This means density equal to mass over volume, okay? And this one is a summation. Summation means different. You have different materials, so you have different materials volume. You have different materials the weight. Then total together, then you can get the final density. Okay, understand? So this one is a test. Then team will make some error, tell you, then you show the calculation of density of error. Okay? Very easy, right? Just a calculation. And how to exchange the weight percent to volume percent is very important. That's two key. Okay? Let's go next. Okay, so I went down here. You just can understand. Very easy because this one is easy to do. Okay. And this one is a function of T is dependent on temperature. Okay, so our test room temperature should be controlled in 15 to 30 degrees C. I think it's easy. Okay. Okay, then we're talking about the volume. Volume is X and Y and Z. If S equal to Y and equal to Z, so equation 2 is we just use this one. It's easy to calculation. Okay. Then this is our oversize. This is we define. This one is S. Okay. What is S? Okay. This is a zero part. So we call this one as S. It's an after center, just like this one. We call this one. Yeah. Then Now this color is green palm. The size is very bigger, and after sintering, silver palm will sink. I'm sorry, I have no same task to comparison, so you maybe some mistake. Okay, so just take this one. I just open this one. Okay. Okay, listen, like the checker. Okay, so the strength is not so good. After sintering, it's a true metals. Okay. Okay. So this one is silver. So silver is close in your design. Very close design, you're successful. Right? So this one is close always we say this one is SC, is cavity. This is the tooling size. So it's bigger. So this one is bigger than over 1. Okay. Normally we just set up in 1.16. So why is 1.16? So that's a cutting here. Okay. Sometimes somebody will say, okay, this is cavity. After cavity, this is green palm. Why? Green palm and cavity sometimes are different. Yeah, it's true. Yeah, because we want the injection molding. You remember this molding? I just said we use the injection molding, use a very high pressure. Remember? And the high pressure will let this one go into more material will inside, then cooling down. After cooling down, it will shrinkage. If this one no shrinkage, you cannot release from the tooling cavity. Am I right? Yes, you will cannot release. Okay, so remember. Okay, remember that's review last week injection molding. Okay, do you have been watching the injection molding? No. Play the Lego brick. Yes, Lego brick. Okay, this is our parts. Plastic, like a box. Okay. Then this is die. There is more die. Okay, this is cavity inside. Okay, cavity features. This core is inside. And then we will put the powder. Okay, this is barrel, barrel, screw. Okay, material there. 3D node, transmission node, and meter node. Okay, materials will go out, and the rotation material will go forward into here. The heating, and the injection. Okay, materials will freezing up. This is hot, then we're cooling down. Solid. Here is hot. So we keep in here. And okay, materials go in here. Keeping the pressure and we remove here. Ejecting. Okay. Okay, if this one is a green palm, it's bigger than silver palm. Okay, because before sintering, size is big. After sintering, it will change. So the rate, we call this one is always oversized rate. I think the professional team will another classes is the manual application molding topic, including the real do, because we have an injection machine. We will buy tooling and make the tensor bar. You can do injection and use the bar, go to center, and after center, get a silver tensor bar, broken it, test. It's an interesting classes, but very difficult. Everybody should be classic this one. Okay? So we just jump into this Excel file. The Excel file has one issue is very how to make the volume percent and the OSF relation. Okay. Here just is a metal roller and the binder roller. Normally, we do the job. Do you calculation the moment or check the weight? Which one is quickly? Check weight or check the moment? Weight quickly. Why? Because easier. Yeah, we have a scale and to count how many. But if we want to change check the moment, no moment scale, you need to measurement the dimensions or input the water and calculate the water weight, then switch to water volume and switch back to the material volume. So many difficulties. So for efficiency, we need to volume percentage, then comparison to weight percentage. Okay, so here is within initial design. This is a square, is 10 to 10 to 10. So this one is more than 1,000. It's easier to understand. Okay, 10 to 10 to 10. Then we just make the measurement is how many is this one is we normally use is one oversized machine is 1.1650. Okay, so in MIA this one is normal, but everybody can say where is the number coming, because this number coming is 332 compared with 632 compared with 368. Totally is 1,000. And this one is metal powder. During sintering, metal powder is keeping, is stay there, no burn out. But if the temperature is higher than 600, this one should become 0. So this one, okay, and this one comparison. 开根号3次怎么讲？
开根号，
do cubic 根号3次 cubic 就 cubic 好 okay cubic this one is 10 and this one is what I don't know, just do this one, so please take your calculator and make this one. So this one after cubic. Okay, this one is 8 point blah blah blah. Then 10 over 8.5. We can get this one. Okay, I just make this one here. So if we go there, okay, then we calculation this one is powder E14. Okay, we check the E14. Okay, so this one is I just make the calculation here. So this is the powder, power and the power over. You just get out this one, 1.16. So please, this one I don't want to explain it more because this one is real to test. You just to understand this one. Then after we got this one, we needed we know the voltage. Then we can switch back because here is density. So this is metal density. So we know the metal density, we know the volume, we can know the weight percent. Then we can know the weight percent of metal, weight percent of iron. Then this one is 90.161.9.31 weight percent. So this 2% is weight percent of metal and the binder. This 2% is metal and the binder, and this one is total. Okay, so we can gather this one to make measurement to check. So in next level, for example, like this one. So this one, for example, this material is SU is 420. Okay, so we can check the total weight is 50 gram. We just write down here, and the volume we can switch to change here because we know this density, so we can change density. We know weight, so we can know the volume. Okay, then we just input different materials. This is binder, our binder. Our binder with each density. Okay, each density. Then the weight we design. This is the recipe, ours design. We have 88% POM, PP is 2.5, weight percent, and HDPE 2.5, EVA 1, PW1, SA 4. 1 this one is oxidation resistance. Okay, 1. Okay, then we can understand which this is 20%, so we can know the volume because this one is density. We can switch change, then go back to change. Then totally this composition by the density is here. Totally. Okay. Summation. This one and over summation. Summation this one over this one. So we can gather this one 1.354. This is about find the density. Then again we combine this one together. Then this one is we just metal is the volume rate is 55.4 and this binder is 44.6. So we go down here and do calculation. Because we just know the 50 kilos. So we just count how many binder in here. This is weight. So then we know these numbers. We can write down to here. So this one here. Then we separate each one the weight percent because we have to design in here. Okay? So this is easy to calculation. I think Tim will not mention here because this is just a powder metal principle, not the MIN. But next, if you want to get the MIN classes, you just have to understand this one more detail. So I just give you one paper here. Okay, in English, please. Okay, this time you will copy this for the whole. Okay, then I just write down last week all class in here, and because we lost the last week, just review here. Okay, and this week we're just talking about 3 ones. This one is today we're just talking about powder science, simple powder science. Sorry, not really all English, because I have no time to translate it. But some keywords you can understand. Okay, should be repeat again. Then this one is what is OSF, and this one is the symbols. Okay, this table in industry is needed to money back. Okay, how much money? I teach you the one recipe. Is 1 month is 10,000 RMB. So total is 1 month, and 20 is 1 month. So total is 240,000 RMB, 2 years. Cost, every course 1 month, 2 days. 建成努力就是 do this one, sales recipe. So please, this is money. Learn the money from your book, from your knowledge. Okay, very important. So it's two. Okay, and this one you can check also in the first side, the set. Okay, just talking about how to make a vision and how to principle. Okay, so this one is very important. So always with SC and XC and XS is means owner is cavity. This one is zero part. Okay, so this is big, this is small. Okay, very easy to understand. And I just assumption this one is 10. So this one is equation like this. Okay, please, everybody should be remember to understand this one. Okay. Anyway, we have some abbreviation, okay, so many this one should be understand, and that's why I'm here. And then you need to understand. And for example, 3104, this is green, and you need to understand each one. Don't worry, when you do the material science, so many kind this times, you need to understand each word, okay? Especially you, yeah, very important. You are a PhD degree, like a dictionary. Before, we have no computer, we have no website. In my PhD degree, when I was the second year, the coding just by a laser jet machine into them, exchange public laser computer and printer and paper. Because it is very easy and quickly. Long time ago, I'm a junior, and holding just one report. The one report is in PM 5 o'clock. Just say, hey, good luck. I will go back home. And tomorrow morning, you have to print 24 to 40 pages for me. Yeah, you just leave about 1 paper or 2 papers, and write down something, and needed to write down plan, information for applying the money from the country. So it's very important. So now it's very easy. We just everything can check it. Compare with go to China, in more lucky. In China, just a something good, something not good, but for information and information correct, I think Google is great. Should do it. Okay? Okay, this is a lot of explanation. Okay, just the final just make it stable. Like you watch. So this one today, all classes information and papers are going to for professional team. So please one requirement bring empathy USB copy. Okay. Everything can share. Everything can open for everybody. But you just have to know what's the meaning, what's this one talking about. You should be understand. Anything else? Any question? Dennis, do you have a question?
No.
No, please. We interested you. Could you is introduction the airplane fix something? Yeah, talking about the interesting story for us. Yeah. Different subject, but it's always an engineer subject. It's my cousin. 他在长隆，然后长隆完以后去哪里德航，然后他成为亚洲区3个有拿到德航修飞机证。他是我们的传奇人物。
你比较传奇。
我是怪咖。